The main loop that we use in Java is called the for loop. And this is used when we know how many times we want something to loop. We can define that in advance or from the start. And here's roughly how it looks. For, and then we have three different pieces of information we need inside of the loop. We need our initial condition, we need the ending condition when the loop ends, and we need the change each loop. What changes each loop? And if you hear my baby in the background, she's very cute, I promise. No problem. So let's set up a loop here. For with the open and close bracket. And now the initial condition needs to be some kind of a variable. So normally what we'll do is actually define a custom variable just for this loop. And we usually just use an integer because we're going to use whole numbers to determine how many loops we want to run. We don't usually run 2.3 loops. We would run 2 loops or 3 loops. The idea of like a fractional loop doesn't really make a lot of sense. So typically, we might use a variable called I. You could use n for the number of loops that have been done. You can put whatever you want, num. You can put a. You can put boop. You can put whatever you want for the word. But I is often a term that you'll see people use for loops. And we're going to start at 0. This is the initial condition. Our variable I is at 0. And our ending condition, or I suppose a better way of saying this is our limiting condition, because it kind of encompasses the whole range of values the loop will run in. I'm going to say I is less than 10 as an example. We'll come back and see some other options in a sec. And what changes each loop? Well, in this one, I just want I to go up by 1 each time the loop happens. Now let's add some content with the squiggly brackets. So let's think about this logically for a sec. We're going to start at 0. This is allowed to run as long as our variable I is less than 10. And every loop, I is going to go up by 1. So make a prediction. How many times should this loop run? I'm going to sout this and say I ran. And let's see when I run this. I ran. Went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Starting at 0, go up to 10, but not including 10, going up by 1s. Do it 10 times, basically, is what this says. What if, instead, I said less than or equal to 10? And actually, just to make this a little bit clearer, I'm going to add a bit more content in here. I ran, and I'm going to concatenate this with I times. I'm actually going to print out how many times I've actually gone through this loop while I print out the message. I ran 0 times, I ran 1 times. Don't worry about the pluralness. I ran up to 10 times. So this is actually 11 times because 0 counts as the 11th one. The including the equals adds this extra one at the end. So maybe what makes more sense here is to start at 1 and then reach 10. And how this loop works. I ran 1 times up until I ran 10 times. Perfect. So I can define how many times I want this to run. Now, maybe I want this to run a lot more times. Maybe I want to say something like, let's go with the famous, I guess what would you call it? It's just a song, and it's to be kid-friendly of Pop on the Wall. Have you heard of this one? The Pop on the Wall song. Let's print out a message that says how many bottles of pop are on the wall, and then we can say take one down, pass it around, and there we go. So to make this work, normally the song starts at 99 and then goes all the way down to 1. So how could I have this whole song be played out in a single loop based off this information? Well, our initial condition, where we're starting, is at 99 bottles, and we want to go as long as I, in this case, is greater than 0. Maybe actually I want to include 0. No, I don't want to include 0 because 1 is the last bottle we want to take down. And this time, we're going down from 99 to 0. So minus minus. What's going to happen when I press run here? My program is going to perform the entirety of this song. And it bottles of pop on the wall, take one and pass it around. Bottles pop on the wall. And I didn't add all the information for the slug itself, but you can see that this loop automatically did all these calculations. And I could include some conditional logic to be able to print out the right messages at different phases of this. But the main core idea is here, is that we have a loop that performs actions as many times as we want. And we'll be using these types of loops all throughout our work to have really condensed, succinct logic for doing repeated actions over and over again.